domain of this thing, we could say the domain is 0 to 9, but don't include 9, union 9 to infinity. Okay. So if you type this in the calculator and graph it, you'll end up getting very close to -6. So we suspect the limit's equal to the -6. The question will be, how do you do that algebraically? So I'll show you 2 ways to do that. All right. So solving these algebraically always depends on rewriting the original expression. So here we go. Multiplying by the conjugate would do this. Rad x plus 3 and rad x plus 3. And what's so nice about that is the denominator, what it turns out to be. See, when you multiply conjugates, let's think about what happens here. Right? So you get a times a is a squared. A times b is plus ab. Then you have minus ab. And you have plus b squared. Well, here's the beauty of conjugates. The middle terms always cancel, and you only get the first term squared minus the second term squared. Right? So you could speed this up. When you multiply things like this, I don't think it doesn't bother me. Just do the first thing squared, so it's going to be rad x squared, or just x, minus the second thing squared, which should just be 9. Now on the top, it's advisable not to try and multiply that out. Because if you don't multiply out the tops, you can easily see what cancels. If you take the time to distribute this 9 minus x into the rad x plus 3, you're going to get something with 4 terms, and you're not going to see what cancels for you. But look now. These things divide out, you get -1. So what you end up with is the limit as x goes to 9 of -1 times the rad of x plus 3. So this turns out to be -1 times the square root of 9 plus 3, or -1 times 3 plus 3, or 6, or -6. So that's one way to get the answer. It's sort of fun. Conjugates are a nice way. Now, it's funny, when you look at this problem, maybe some of you had this thought. When you first look at it, you have a 9 minus x on the top, and then you have what? A rad x minus 3. So I am sure somebody thought to themselves, I wish that numerator had been 9 minus x squared. I'm sure somebody had that thought. You just look at it, you think, well, that would be great. Because we know how to factor that very easily. It's 3 minus x and 3 plus x. Sometimes you call this the difference of 2 squares. And why we like it is because 9 has a square root. The square root of 9 is 3. And then x squared has a nice square root. It's just x. Okay. So if you want, we could think of this factoring as really this. It's the square root of 9 minus the square root of x squared times the square root of 9 minus, or plus the square root of x squared. And if you look at it, that's really the same expression as this expression up here in blue, right? But when you look at it this way, what you realize is you can force factoring of difference of 2 squares onto other problems where one of the things might not be a perfect square, right? So if we take that 9 minus x, this thing in the numerator here, the 9 looks good, the x doesn't, but I'm going to force it. I'm going to say, hey, this is the square root of 9, so 3, minus the square root of x, which I don't know, or I can't simplify, right? And the square root of 9 plus, the square root of 9, which is 3, sorry, hold on a minute there, plus the square root of x, which I'm not sure how to reduce, so I'm just going to leave it there. And then on the bottom, I have the square root of x minus 3. And look what happens. These divide out, giving you -1. You end up with -1 times 3 plus the square root of x. That's a familiar expression. Why am I saying it's familiar? Look up here, and you'll notice that you basically had the exact same thing. Now that. So this turns out to be the same thing. -1 times 3 plus the square root of 9, or -6. You get the same answer either way. So let's move on to a new problem. Let's consider this limit. The limit as x approaches 4 of 3 minus the square root of x plus 5 over x minus 4. I'd like you to try this graphically and then algebraically. So when you try and plug in 4, clearly it's undefined, but if you plug in 4 on top, a neat thing happens. You end up with 3 minus the square root of 9, which is 0. On the bottom, you have 4 minus 4, which is 0. So like I said earlier, if you get 0 over 0, there's probably a way to factor and reduce this and make the limit work. So let's try that. I am actually going to multiply by the conjugate of the numerator. So this might have been less obvious to some people. Let's see what happens when you do this. So here's an example of speeding up the process. Ready? Multiply the first things, you get 9. Minus, multiply the second things, x plus 5. And you'll notice I never bother with the middle terms. It doesn't matter. And on the bottom, I am not going to distribute anything. And that's a good thing because I don't really want to. Let's keep going. If I distribute this, I end up with 9 minus x minus 5. Or really, with 4 minus x. So watch this. 4 minus x over x minus 4 times 3 plus the square root of x plus 5. And sure enough, these divide out to negative 1. So you're left with the limit as x goes to 4 of 1 over 3 plus the square root of x plus 5. But now I have the luxury of being able to sub this in. So I get the square root of 4 plus 5, which is the square root of 9, which is 3. So it's 1 over 3 plus 3, or 1/6. I better be careful not to lose my negative. When I divide out, I got a negative 1. That should be negative.